Hello and welcome to this tutorial in Blender 2.7 and TouchDesigner. In this tutorial I'll be showing you how to create this type of animation, which I've seen a lot in different VJ sets and some projection mapping and installation, media installations around different videos that show an object or a building or something being broken up into bits and then flying apart in some way. And this is pretty easy to do in Blender to create this type of effect, and then port it over into TouchDesigner where you can do some work in the UV editing and showing different videos on it, or using this as some type of playback raster or what have you. So let's get started. I'm going to close out of TouchDesigner and open up a new Blender instance, Blender process. I'm going to be using an old file from a previous tutorial called Camera Mapping, where we took a single image from a camera phone and generated all this 3D content. Very useful technique. I urge you to go watch that video in order to create some content. If not, play around by yourself, or you can download this blend file and use it to your liking. So first thing I'm going to do is I'm going to map this. I'm going to create a UV map for this as just a mask. I just want the outline of this map to an image that I can edit later. Nothing too fancy. I don't really feel like having full control over each of these surfaces. Just slap an image on there kind of deal. So in order to do this, I'm going to go into the UV editing viewport and then select the object that I want to map, go into edit mode, view through the camera, and press A to bring up its UV map. So this type of UV map I'm going to do is called just a project. So we're going to press U to open up the UV mapping menu, and then project from view bounds, which is going to make a version of what we see here, only fit in this bounds, which is very useful as you'll see right now when I turn on the texture. This is all just one image being projected from a single source, basically. So, if I just shown an image through a projector onto this, this is what it would look like from this angle. But I have discrete control over that in front of these walls instead of, so it's just a mask basically for a single image. Pretty useful when you don't really need the whole infrastructure behind it of individual surfaces. So back into object mode and back into my default viewer, and we're going to start working on breaking this thing up. And Blender makes this pretty easy with an add-on called Cell Fracture. So if you go into File, User Preferences, you'll be confronted with this GUI. You'll go over to Add-ons. In the search bar, you'll search for Cell Fracture, and it should be the only thing that comes up if you type in cell. If you click the checkbox, it will be added to your tools that you can use, which there it is. If you go to Tools and then down to Cell Fracture, bam. Cell Fracture is a really useful add-on that allows you to just break up things randomly. There's a bunch of parameters that you have control over, like the amount of objects you want to get out of the fracture, the amount of recursion. So if I break this guy into a chunk, then the recursion would break that chunk into a chunk and that chunk into a chunk, and you can actually go all the way down to dust, but that's a lot of cook time that we don't really have time for in this tutorial, so we're just going to stick with the default parameters in here, which will do just fine. And if you click OK, you're going to see it show progress in real time. So it breaks all of that up into various cells and then moves all of that over to the second layer, which you can see down here. These are all of your Blender file layers. If you go over to the second one, bam, we have all of these rip-roaring ready to go, all separated out into their own individual chunks. Great. So here's another useful thing that Blender does. I don't want to sit here and render out the physics of this guy moving in any kind of way. That sounds like it's very tedious and just not something that I'm really interested in doing or spending my time doing. So what we're going to do is add a rigid body world into this. So treat all of these like they have mass, and then simulate some physics in order to do that animation, which is pretty easy. Blender has a tab specifically for physics, which is over here. And if you go into here, you'll see a bunch of different physics you can have. You can simulate cloth or smoke, fluid, a lot of different things. But the one we're interested in is rigid body, which basically gives this cell mass we can use later. Great, so this guy, if I click play right now, he'll just fall forever into the abyss that is Blender, right through the rest of his meshy pals. So we want to give all of his meshy pals some mass too, so they can fall with him, so he's not alone. In order to do that, we're going to select everything in this layer by pressing A twice, then go to Physics, make sure that you've selected the cell that has a green outline. That means that it is a rigid body if you've set up the rigid body already. And then select all of them and say copy from active. And now all of them should turn green, and they're all best friends because when we simulate this now, they all fall together under the gravity of the default Blender world. The simulation that I want to set up, the gravity is actually pain in the butt to work with, so we're going to turn it off. And to do that, you're going to go over to your scene settings and go down to your gravity menu and just set that Z negative 9.8 to 0. Now if you play this through, they'll stay still, all in their happy little shape. Cool. Now we want to tear them apart like they're getting abducted by aliens, upward, just like in the preview of this tutorial. And in order to do that, we need to give them a thing to be attracted to. So in order to do that, we're going to go to Create, Empty, and then move this empty somewhere in space. I put this in the preview all the way up here because it's out of our camera view. Then we're going to go back over to that Physics tab, press Force Field. So we're going to create a force field around that empty, which has a negative strength. So instead of pushing things away from the empty, we want to suck things into it. So negative 10 should do nicely. And then if we simulate this, we should see them starting to pull upwards. Yeah, there they go. Cool. And the reason that didn't do that for so long was because we already had cached frames. Before, when we simulated, when we pressed play on the simulation with zero gravity and they didn't move, that cached a bunch of physics frames into the first few slots here. And that's not really what we want. At the end of the day, we want this thing to pull up the second the animation starts. So we need to clear that cache, and the way you do that, the fastest way I've found is to just select one of these cells and change one of its properties, deselect dynamic and then select it again, and that will recompute all of that cache. So now it should take off right away, which it does. Awesome. So this is pretty cool. This could be made into its own thing right now, but really what I'm looking for is a way to pull the top, then pull the middle, then pull the bottom. So things, there's a gradient to the way physics acts here. So we get to see more of the inside, and we get to see this thing break up more before it goes out of view. Easy way to do that is to select the empty. We have minimum and maximum range, and we're just going to select maximum, and this is basically like, where is my sphere of influence around that empty? And as this increases, that maximum force increases as well. And you can do gradients with this, but that's a lot of work to make that happen right now. So what we're going to do is set this maximum to 1 in the first frame, right? We're going to create a keyframe. To do that, you hover over the maximum and press I, and it'll turn yellow, meaning that you have a keyframe in that slot. We're going to take our timeline and move it to frame 40. Then change the maximum to be like 13, I think. Hover over again and press I. You've just created another keyframe at frame 40. So now as this scrubs through, we'll see that maximum go from 1 to 13, which will increase the size of the force. Now what we need to do is recompute all of that physics. So just select one of your cells, press dynamic, and then recheck that box. And now everything should recompute to that. And as that sphere opens up, we'll see it all take off. We have some leftover bits. That's not really good. We will take care of that, and the way we can do that is selecting empty, going to frame 40. It looks like we're just not getting it in that sphere of influence. So if we bump that up to 14.7 and then right click replace keyframe, we should get those now influenced. Right, we have to recompute the cache, and let's give that another try. There it goes. Great. They're all breaking up in their own. There's a gradient. The top is getting pulled, then the bottom. That's what we're looking for. Cool. So now we need this information to go into FBX, and as it is right now, it won't be saved into that FBX in a way that TouchDesigner can use it. In order to save it, we need to bake all of this physics into keyframes. So we need to tell the origin exactly its transform, location, rotation, and scale. To do this, you're going to you're going to click in your viewer window, press A twice, deselect your empty, then go over to your physics tab, and what is going on? I should have a bake keyframe. Make sure you select one of your cells, bake to keyframes, and we're going to bake up to 150. Actually, let's do 250. That'll be fine. Press OK. It's going to think for a bit while it computes all of those keyframes, and then you should end up with all of those yellow lines are individual keyframes of each of these cells. So if we play this back, we'll see that all of those go up, and woohoo! That's awesome. Great. And actually, since those are baked now, we can get rid of that empty, which I mean, you don't have to, but just to show the proof here that those are baked into keyframes and not acting under physics. There it is. Great. So we have that part done. We have this animation that's rip-roaring ready to go, and we have our previous set with our camera. Let's throw this into, let's export this as an FBX. So that was File, Export FBX. Then you're going to want to make sure that the version is FBX 6.1 ASCII. find a nice folder to save this to. I'm going to save this as Pol3. Export. Cool. And now Blender's job is done in this equation. So let's close out of it and open up a new process of TouchDesigner, which will take a second. And I apologize if my computer fan turns on. I'll try to speak up if it does, but TouchDesigner really likes to challenge my computer's GPU fan. So let's get rid of the default network and import a new file. So you do that by going up to File, Import File. You're going to navigate to whatever folder you saved your FBX to and open it up. You'll be confronted with this GUI, which just basically asks you where you want to import the file to. TouchDesigner is going to go into that FBX and break up all of the meshes, images, and different channels that you're using into individual files that TouchDesigner can then use. So I usually just go with the, if it's not really important, I just go with the default settings. So if we press import, create, it will go ahead and your command prompt will go crazy for a second while it imports all of that geometry, but at the end of the day you'll end up with a geometry comp which is playing back your simulation. If we take a look inside here, we'll actually see all of those cells lined up. Those are all geometry comps that are functioning through the animation of the export anim, which is coming from a base which holds a file in which has all of the channels for what we're currently using. And first thing I want to do is take out the static stuff. So anything that doesn't have the name cell attached to it was from that first layer. And we're going to copy that, delete it, and bring it out to the top layer of our project. If we dive back down inside, the first thing I want to do is set up a playback option for this. So I don't want to have this locked to the timeline anymore. I'm going to go into takes, and this is where that time slice is happening. That's taking information from the timeline and looking it up from the default take. In order to bypass this, I found the best way is to add a lookup chop. Take the default take file into the lookup table, and then create a select, which is looking at a null at our top layer. We'll call it null 1. That null is driven by, for right now, let's drive it from a constant. So now, if we go back into takes, I forgot to do this, we need to disconnect the default take time slice and then connect our own lookup chop into the switch. Now, if we scrub through the constant, we should see that animation playing. The last frame is actually a reset frame, which is kind of obnoxious, but if you go all the way up to 0.99, you won't have any trouble. It's when you go back to 1 that it resets. But for the time being, that should be fine for us to just play back through. So let's look a little harder at the geometry that's going on here. All of these cells, there's 100 of them, I think. If you look inside of one of them, it's actually two parts. There's the inside of the cell. So when we break it up, it creates another geometry inside where you broke it up at the boundaries of the cell, and then the outside geometry. So whatever geometry wasn't broken up by the cell fracture. And if we look in here, each of these has their own mesh and their own geometry, or their own map file, or their own map texture, which it's referencing. Both of them the exact same thing. That can be a little obnoxious to work with because all the way out here you can't set material and have it affect those inside. And you certainly don't want to go through each and every one of these where there's 100 of these and set 2 materials per. That would get a little tedious and a little boring, so why not let TouchDesigner handle that? We can assign materials programmatically, and I'll show you how to do that right now. So go back to your project 1, inside project 1, and create a new text app. When you do this, this text app is going to be useful because it's going to hold all of our programming to copy materials into each of those split geometry mats inside of all of those columns. So we need to create what we're copying into them, and that is going to be a select map. This is going to be useful because it's going to be pointing to a null all the way out here, which we can then control separately. So we're going to create 2 of them, one for each of the split geo mats inside of here. So each one of these will have its own material that we can select from. And then the other thing I'm going to do is split this pane left and right, just so I can move around a little bit while doing the coding. Cool. And now we have everything we need. First thing I'm going to do is, in these selects, I'm going to edit the select map. We're going to call for a null that's 3 layers above us. So basically where this map will end up living is inside here and then inside here. So we want to be able to control this material from this layer of our network, which means 1, 2, 3 up. So / / 3 times, and then we're going to call this material that we're referencing, we're going to call inside map. And then in select 2, we're going to create a material that's also 3 up, and we're going to call this outside map. So these are currently referencing materials that don't exist, but we'll make them exist right now. You're going to create 2 nulls, one called inside map, and the other called outside map. Cool. So these are still not referencing these 2 thongs because these don't actually live in the same in this layer. In order to do that, though, we need to create some programming that makes this a lot easier for us. So I'm going to create a new this text app is what's going to hold all of our referencing. Sorry about that, I was a little distracted. So there's a method in all operators, all component operators called children, and this looks for the children of the component and reports it back as a list. This is going to be extremely useful to us in this program. We're going to create a call called create a variable called opChildren and assign that variable to be op_3, which is this component here. So op poll 3 children. This will return a list of all of the children in op3. So every operator in here will get returned as this list. We're then going to iterate through that list. So for each child in op children, we want to check with an if statement if that child is an object. And objects are all of these in here. So 3D objects, anything that exists in poll 3, any operator that exists in poll 3 that is any of these objects, we will get true in this if statement. So if child is object, we want to then look at all of its children. So if there's an object, which this plain cell is, look for its children. For grandchild, in child, if grandchild dot is object, right? Because you might have an object in here, right, that holds that doesn't hold another object, right? And we don't want to be trying to set the material. We wouldn't be setting the material. We'd call back an error if we didn't do the second check. So make sure that whatever object is you're looking for, make sure that the grandchildren are objects. So that'll return true again, if it is. Then we want to give split geomat 0 select 1 and split geomat 1 select 2. And in order to do that, we will just call grandchild dot copy. And this will copy from wherever text lives an operator and put it inside split geomat or the grandchild. So we want to copy op select 1 into split mat geo, and then set the grandchild's material to equal the path to that select, which is inside of itself, and then select 1. Okay. Great. So that will set every single grandchild as select 1, which is something we don't want. We want to select, we want one of them to be select 1, one of them to be select 2. So this is where we can check again with another if statement. If grandchild dot name is equal to split geo mat 0, and this is a boolean, so if it's equal, then do these two things, which we need to indent. Great. And we can just copy this guy again, come down to here and paste, and then ask if it's mat 1. And if it is, we're going to copy in select 2 and set select 2 as the material. And that should do us. This might throw back an error, but we'll run through the debugging if it does. And it did. So what did I misspell this time? Invalid syntax for opt. Oh, what did I do? Oh, it's always the smallest thing. For child in op children. Run script. What else is wrong? T null object is not durable. I have never gotten this before. That's fun. Oh, that's why. It's seriously, coding all comes down to we need that list, right? So we need to run that children again. This should function. Great. Awesome. Sorry about that. Getting late here and missing some parts of my script. Great. So now each of these should have the assigned material in them. So select one is in split geomat 1. And if we look at parameters, it should be set as the material as well. Awesome. And we just did that for all of those in less time and less aggravation that it would have taken had we gone through and copied and pasted. Cool. Let's close out of that and start looking at what we can do here. We can delete select 1 and 2. We no longer need them. And we'll create a new Fong shader that can go into each one of those respectively. And we can see if we give these different colors, we can see where each of them live. So we have the blue on the outside and the red on the inside, which you can see in those tiny little cracks. And if we play this through, you'll be able to see the red. There it is. Right? So it's on the inside of that. Cool. I suppose next is making some kind of neat animation for this. And easiest way I know how to do that is to use a timer. So I want this all to play back when I press start and for it to reset when I press in there. Right? And we are going to do that with a speed. So if you insert a speed into this chop run and give it a limit type of clamp because we don't want it to go above 0.99 because we don't want that reset frame. And then in the timer 1 callbacks, if you go to on done and say op constant 1 is op constant 1 dot par dot value 0 is equal to 0.2. We should see when we start this bad boy up, let's change the length to 3 because I don't want to wait, that this will be set to 0.2, the speed will go, which will play our animation. Awesome. Cool. So now when the animation's all done, what I want this to do, when the animation's all done, I would re-init, which would reset everything and reset my animation. So I want to create the program to reset my animation now. So if we go back into our timer 1 callbacks, on initialize, which is the callback we're looking for, we want to set op constant 1 dot par dot value 0 to equal 0 again. Then we want to set op speed 1 dot par dot reset dot pulse to reset the speed, so it all resets. And there you have it. That should kick us off. So if we play through, if we start this, if we initialize, everything should reset, and then if we play through, everything should run down once that timer hits 3. Cool. Great. Now I want that countdown timer to actually be on my geometry. So we need to set up a text top, which will be reading in the timer. And I'm going to set the output to be timer count seconds. And then in text, we're going to do some scripting which is op timer 1 dot par dot length minus op timer 1 dot or sorry, not dot this time, bracket timer underscore seconds. Close bracket. Great. And then we're going to set this text to actually evaluate the expression, the Python expression. And it's a point value, which I don't really want. I want that to be an int, so I'm just going to add in the int brackets really quickly. Cool. So now that should be an integer. Great. And if we start this, we should see that start to count down. Bam. Cool. So we're going to apply this as the emit map to Fong2. We're going to turn the emit value to 1. Diffuse value, we're actually going to take down to 0.2 across the board, just so there's a little something there. Actually, let's make it 0.1. There's a little something there to reflect light, but mostly it's that emit map. And we should see this if we reinitialize. There it is. Now, we want this 3 to actually be centered up in that one corner. And in order to do that, we're just going to go to this top, which is now acting as that UV map that we saw in Blender. You know, the same coordinates will apply, and I know that it was somewhere up here was where that surface was. So I'm going to go to font, and then position, and move that position so that we line up. Awesome. So now when we start this, we'll see a countdown. 2, 1, and then everything goes upwards. Cool. So, I mean, this is the general geometry that's happening right now. Let's render this out and make it look a little better. So we're going to add in a render top, which is going to take all of our geometry, which we don't want. We just want it to take in pole 3. Then we also need to add in a camera. Here's a little neat tidbit. TouchDesigner imports the camera from Blender. You can see it here, camera converted to TD. And I'm just going to use that one. You can add in your own camera with its own kind of parameters if you would like. I'm just going to use that same camera though. Great. Last but not least, let's add in the rest of our geometry. So we want the floor and the 2 sidewalls there. So open up the parameters to render. In geometry, we're going to type in plane underscore 001. We're going to then copy that, paste it as 002 and 003. And now all of those are rendering out. We're going to add in a light, which will just give us a little bit of minor illumination. We're actually going to turn down the dimmer on that. Look how bright it is. There we go. Cool. And what we see now is that same kind of look as we had before. I'm going to change this Fong so that the diffuse actually doesn't exist. So zero everything out on the diffuse. And then the emit we're going to change as well. We're going to give this a nice electric blue color. Woo! Iron Man. Have a blue. I don't know, somewhere in here. Sure. Great. Cool. So that's now emitting, and if we play that back, we can see how that works. 3, 2, 1. So that's kind of like, it's a little boring. Like the constant blue just doesn't look like light to me. It looks like it's just a color being lit up. I know it's emitting, but it's not. It doesn't really look like light to me. In order to make that look a little better, what I found is really great for rendering light is taking a blur top and a composite, bringing those two things together, blurring the original, and then compositing the original on top of adding the original to the blur. It'll give us a nice kind of blurry effect. I'm going to swap that out. And we can just edit this blur so it looks a little better. Great. And if we play this through now, we'll see that that light is actually like a thing. Right? Like that glow is so nice. It really helps. And there are ways of rendering this so like the rest of your scene doesn't get blurry, but we won't really get into that now. But that glow effect is really what I was after. Definitely makes it look a little bit more like light, which is good. So that's just about where we left off. That was the what I showed you in the beginning of this tutorial. The only thing we have to add is a button, and in order to do that, you make a button, give it a name like start countdown. Turn on word wrap. Adjust the font size. Oh my goodness. Configure start countdown. Yeah. Cool. Close enough. Go into DAP, panel execute. When the button turns on, we want op timer, which is outside of us. Timer 1 dot par dot start dot pulse bracket. And then when it goes from off to on, or sorry, on to off, we want op timer 1 dot par dot initialize dot pulse, and then make sure you turn on to off. And now when we press this button, it should run that countdown. Whew, everything flies away. And then when we press it again, it should reinitialize everything. Great. Am I forgetting anything? Oh, last but not least, the pulsing of the light on the inside, right? So let's set up this chop network pretty quick. I was doing this with a LFO, a math, and a constant, and another constant. And we're going to set this constant to 1, this constant to 0, feed that LFO into the math, change the range to be from -1 to 1, and then feed all of that into a switch. and then a null. This null is then referencing or is being put into a constant top, which is controlling the alpha. So let me make this into an interesting color again, and then we'll set it to alpha. So now it's pulsing that alpha, which we're going to set as the emit map of the font. Oh, that color is not cool. There we go. Yeah, nice light blue. That's nice and cool. All right. So now in our timer callbacks, we're going to control this switch. So on initialize, what we want is for that switch to be at index 1, which is the 0. So op switch 1 dot par dot index is equal to 1. We're going to copy that. And then on start, we want that to be index 0, and then on the init, we want that, or sorry, on the done, we want that to be 2. So, if we re-init this timer, bam, everything should turn off. Once we start it, it starts to pulse, and then once it goes, it remains constant. And that's that network for you. You know, just some minor things like take the last component or the last top and take it to an out, and then if you make all that and then throw it into a perform mode and start that countdown, we'll have the exact same thing as the beginning of the video. Thanks so much for watching. Please feel free to email me if you have any questions, or I'm always on the forums and I'm always on the help group, so if you have any questions, contact me there. Or the new Slack, that thing's awesome. Yeah, give me a shout. All right, till next time. See ya.